Geothermal energy is derived from the heat of the Earth, delivering a reliable supply of clean, renewable, and baseload power. Electricity generated from geothermal energy is sustainable for the environment.
Unlike other power plants that rely on the burning of coal or other fossil fuels, geothermal power plants have low greenhouse gas emissions, harnessing the naturally occurring energy from the Earth's geothermal resources to generate electricity for homes and industries. Geothermal energy is a lot like boiling water in a kettle. We call this the kettle concept. Instead of using a stove burner to boil water, geothermal energy uses the heat of the Earth. This is how it works.
In geologically active areas such as the Philippines, the natural heat of the Earth's interior extends relatively close to the Earth's surface, creating conditions favoring formation of geothermal resources. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs in the hot rocks, heating the water to temperatures in excess of 250 degrees Celsius.
To reach this high-temperature, high-pressure fluid,
geothermal wells are drilled to a depth of 1 kilometer to 4 kilometers below the surface of the Earth.
These production wells then bring the geothermal fluid to the Earth's surface, where it can be used to generate electricity.
Because of the high temperature in the geothermal reservoir, the deep fluid partially boils and naturally flows up through the wellbore and surface facilities.
Geothermal fluid passes through the wellhead and pipelines before it is sent to a separator, where the steam is separated from the hot water. The separated hot water, called brine, is then injected back into the reservoir, where it is reheated by the hot rocks and eventually reused. This is what makes geothermal energy renewable. From the separator, the steam is delivered to the power plants through a system of large pipelines above ground.
These steam lines may have a diameter as big as 1 meter and are insulated to prevent heat losses as they traverse terrain of up to 3 kilometers. Underneath the insulation, these steam lines are extremely hot and will expand when filled with steam, which is why there are expansion loops every few hundred meters. The steam passes through a final cleaning process to remove condensed water and traces of other impurities in what is called a scrubber. The processed steam is now delivered to the power plant. The pressure and heat energy in the steam are used to spin the turbine blades. The turbines turn a shaft connected to an electrical generator. An electrical current is created when magnets rotate within the generator. Large copper bars carry the electrical current to a step-up transformer outside the plant. Within the transformer, the voltage is increased before the power is sent to the power lines, substations, and distribution lines that carry it to homes and industries. The clouds above the cooling tower are exactly that, clouds of water vapor. The water that is not evaporated into the atmosphere is called condensate. This excess condensate is collected and injected back into the reservoir through injection wells, where it will be heated up by the hot rocks and eventually reused. Like the separated brine earlier, this is another part that makes geothermal energy renewable.
Compared to other sources of electricity,
geothermal energy is a clean and green energy source, helping us mitigate the effects of global warming and climate change. Geothermal energy is renewable because with proper management, a geothermal resource can remain a reliable source of energy for several decades.
The advantages of geothermal energy are numerous. It is a reliable energy source and reduces dependence on fossil fuels. Geothermal power plants practically emit no greenhouse gases.
Philippine Geothermal Production Company Incorporated operates the Tiwi steam fields in the province of Albay and the Macban steam fields in the provinces of Batangas and Laguna. Our pioneering partnership with the Philippine government in 1971 has transformed a 2.5 kilowatt experiment into the first commercial geothermal power project in Asia and led to the birth of the geothermal industry in the Philippines. The Tiwi and Macban geothermal fields supply steam to third-party owned power plants with a total installed capacity of 637 megawatts. Geothermal resources represent a significant energy source in the Philippines. 1 out of 6 light bulbs is lit by geothermal energy. As the country's pioneer geothermal energy producer, we at the Philippine Geothermal Production Company Incorporated remain strongly committed to deliver clean, reliable, and renewable geothermal energy, keeping our operations safe and environmentally sustainable as we improve the lives of our host communities.